Ayan. Okay. So, good day, everyone. So, ang assigned lesson natin ngayon ay about series. Ang learning outcomes at the end of the lesson, the students able to first illustrate a series and second, differentiate a series from a sequence. Yes, ang ating lesson outline, sequences and series, and the difference between sequence and the series. So by definition, ano sinasabi ng mga textbook or ng mga sites about the sequence and the series? A sequence is a function whose domain is the set of positive integers or in the form of the set of 1, 2, 3, and so on up to last n. And that is a form of a sequence. For example, yung ginagamit nating set of natural number or yung set of counting numbers. Ayan. So, pwede natin sabihin yan, that is a sequence. Pwede rin yung set of even counting numbers, also set of odd counting numbers. Yun yung mga pwedeng maging example ng tinatawag nating sequence. How about series? A series represents the sum of the terms of a sequence. If a sequence is finite, we will refer to the sum of the terms of the sequence as the series associated with the sequence. So kung ito palang mga sequence na nakikita natin, kinuha natin yung kanyang total or sum, then pumapasok tayo ngayon sa tinatawag nating series. Basta associated, associated. Itong mga series associated with the sequence. Okay, for more information, so magbigay tayo ng mga iba't ibang example or yung tinatawag natin na notation regarding the sequence. So the sequence with nth term, so we use a notation as a sub n, is usually denoted by, yes, the set of a sub n, and the associated series is given by, we use capital S is equals to a sub 1, which referring to the first term, plus a sub 2, another second term, plus a sub 3, another third term, plus and so on up to the last term. So since we use plus sign in every sequence, so pwede natin sabihin na ito ay isa ng series. Pwede na to in the form of series, no? Kaya ang ginamit natin ay letter S. So pwede na rin siya as, or isa na rin siyang series. Kasi kinukuha natin yung kanyang the sum of. Okay. Example 1. Tingnan natin yung mga pwedeng mangyari ng series. Determine the first 5 terms of each defined sequence. So, ang unang gagawin natin, yes, kuhanin mo natin yung sequence, first 5 terms ng given sets and yung kanyang associated series. Katulad ng letter A natin. So, ang nakalagay dito ay the set of sequence 2 minus n. First 5 terms. So, we start with the first term of the sequence up to the last 5th terms. Okay, so, tingnan natin ang sequence niya. So, ang first 5 terms ng kanyang sequence, siyempre, first term ay a sub 1. Gagamitin lang natin yung yung ating sets na ginamit. So, 2 minus n, so 2 minus 1, that is 1. And the second term is you use 2 kasi second term na eh. So 2 minus 2 and that is 0. Third term, 2 minus 3. Yun yung kanyang magiging solution, di ba? 2 minus 3 and that is negative 1. Fourth term, 2 minus 4. Fourth term na, di ba? Yun yung mga ginagamit natin term mo, yung kanyang sub-number. So, kaya negative 4, di ba? Yan ay 2 minus 4. And the fifth term, and that is 2 minus 5. So, kaya merong negative 3. So, ano-ano yung mga sequence ng ating given sets? So, minus n. So, we have 1, 0, negative 1, negative 2, and negative 3. So, meron na tayong tinatawag na sequence. Then, pag kinuha natin yung kanyang associated series from first term up to the fifth term, so find its total using the adding rule. So we have the series of 1 plus 0 minus 1 minus 2 minus 5. And the result is negative 5. Check. Letter B. So A sub n is equals to 1 plus 2n plus 3n square. Okay, first 5 terms, no? First 5 terms. Yes, ang kanyang first term hanggang first 5 terms ay makikita natin. So, ang A sub 1 natin ay using the sequence form. So, 1 plus 2n. So, that's 1 plus 2 times 1 times or plus 3 times 1 squared. So, meron tayong 6. Okay, check tayo dun sa 6 na. Yun yung ating first term. So, 6. Then, yung second term, following the set of sequence. So, 1 plus 2 times 2, kasi magiging second term na tayo or 2 na yung n natin, plus 3 n's or 2 square. So, yung 2 square times 3, meron tayo doong 12. And then 1 plus 4, that is 5. So, 5 plus 12 is 17. So, check tayo with 17. So, kaya ang second term natin with the sequence is 17. The next is third term, A sub 3. So, kaya naging 34, i-verify natin. Galing pa rin doon sa set natin. So, that is 1 plus 2 times 3 using 3 as the third term. So, we have 6 plus 3 times 3 squared. 3 squared is 9 times 3, 27. 27 ba? 27. Okay. So, 1 plus 6 plus 27, 34. Ayan. Okay. So, ang third term natin ay 34. Next ay yung ating 57. So, nanggaling siya sa 1, 4. Ang gagamitin nating term. 2 times 4, meron tayong 8. 1 plus 8 plus 4 squared is 16. And 16 times 3. Di ba? Kasi meron pa tayong 3 doon. So, 16 times 3. Okay. So, ang mangyayari ngayon ay 1 plus 8. Meron tayong 9 plus 48. Okay. So, 9 plus 48 is 57. Okay. Check tayo with fourth term, 57. And the last, kasi 5 lang naman kailangan natin, di ba? Base dun sa ating information. So, first 5 terms. So, ang last ay 86. Okay, ang last natin ay 86. So, nakuha na natin, na-complete na natin yung ating sequence. First 5 sequence. So, we have 6, 17, 34, 57, and 86. And next, pag kinuha na natin yung kanyang associated series, so ito na ang magiging provide natin. So, the series is from first term plus second term, third term plus fourth term, and the last plus fifth term. So, we have the series of 6 plus 17 plus 34 plus 57 plus 86. Then, it ends with 200. Okay? So, ang ating series ay 200. Okay, next example under number 1. First 5 terms of each defined sequence. Ito yung ating defined sequence. A sub n is equals to the quantity of -1 raised to n. Then, after ng first 5 term sequence, bigay mo yung kanyang associated series. Okay, check natin yung kanyang sequences. So, ang first term, syempre, it start with -1 raised to 1. First term. So, it is -1. Pero pagdating na ng second term, -1 square, and it is +1. Third term, -1 cube, and it is -1. Fourth term, -1 to the fourth, it is 1. And fifth term, -1 raised to 5, and it is -1. Mapapansin mo lang, nangyayari dun sa ating positive and negative sign, nag-alternate. Kasi depende sa ating exponent. Kapag pala yung ating mga exponent ay 1, 3, 5, ito ay mga tinatawag na odd counting numbers, di ba? Add integers, pwede rin, add integers. So, ang nangyayari ngayon sa ating, kung ang ating exponent ay odd integers, ang pattern, always negative. Yung ating sign, always negative. Okay. So, ngayon, kapag naman ang ating exponent ay even exponent, di ba? 2 and 4. Ang nangyayari ngayon sa ating result ay positive result. Okay. Yun yung isang pwede natin makitang pattern. Kaya ngayon, at the end, ang mangyayari ngayon yung ating mga sequences from start with -1, 1, -1, -1, 1, -1. Alternate. So, meron na tayong sequence. And how about the series? So, kuhanin lang natin yung kanyang sum. So, -1 plus 1 plus -1 plus 1 plus -1. And it ends with -1. Dito naman, kitang-kita na yun. No? Pwede ka na maggumamit ng cancellation property, di ba? -1 plus 1. Kasi ano naman sila eh, additive inverses. Kaya ayan. So, mag-end ka sa -1. Okay? Okay, next example, letter D. Determine the first 5 terms of each defined sequence and associated series. Ito yung ating defined sequence. A sub n is equals to 1 plus 2 plus 3 plus and so on up to plus n. Ngayon, ano ang kukuha natin? First 5 lang sa first 5. O, kuhanin natin. Siyempre, yung ating magiging first term, yes, it start with 1. And the second term, 1 plus 2. Sa second term na tayo eh. Kasi yung ating defined sequence denoted by this pattern. Then, ang ating third term, 1 plus 2 plus 3 plus and so on. Okay, 1 plus 2 plus 3. So, that is 6. And the fourth term, 1 plus 2 plus 3 plus 4, it is 10. And the fifth term is 1 plus 2 plus 3 plus 4 plus 5 equals 15. So, ang mga sequences natin ay 1, 3, 6, 10, and 15. Take note, ito ay sequence ha. Hindi pa ito yung series. Sequence pa lang ito. Kasi kinukuha nga natin yung first 5 sequence based on this defined sequence. So, pag kinuha pa natin yung series nitong mga sequences, ang ibig sabihin nun, mula first term hanggang fifth term, i-add mo lang yon. So, 1 plus 3 plus 6 plus 10 plus 15. And the series is 35. And that's it. Okay, so under ng another sequence, the sequence of the set of a sub n defined by a sub n is equals to the first term or the a sub n minus 1 term plus a sub n minus 2 term. Requirements for the n must be greater than or equal to 3, where the first term and the second term is equal to 1. And that sequence is called a Fibonacci sequence. So ito yung kanyang first 7 Fibonacci sequence. Yes, that is 21. Kita niyo ba yan? Oo. Kasi dito nang galing yan. Kung mapapansin mo yung kanyang pattern or yung sequence ni Fibonacci, ayan, nakukuha yung result, parang gamitin mo lang tong formula niyo. Diba? Let's say, paano natin nakuha? So, nakuha natin yung 21 kasi yon ay galing sa 13 plus 8, di ba? Yung 21, yun yung result ng a sub 8. And that is equal with a sub 7 plus a sub 6. A sub 7 is 13 and a sub 6 is 8. Okay? So, ito yung kanyang sasabi natin na equation. Fibonacci sequence. Next, meron pa tayong mga tinatawag na iba pang mga sequence at meron din naman siyang series and formula. An arithmetic sequence is a sequence in which each term after the first is obtained by adding a constant. Ito naman yung mga meron ng constant or yung tinatawag na common difference. Kaya, dahil doon sa common difference, nakukuha mo na yung preceding terms or yung next term. Nakukuha mo na kasi meron nga siyang common difference. So, ito yung kanyang formula. If the n term of an arithmetic series is a sub n and the common difference is d, then The arithmetic sequence is in the form of a sub n equals to the sum of first term plus n minus 1 times the common difference d. Okay? Importante yung common difference d. Yun yung sa sequence, arithmetic sequence. Then, pag kinuha mo naman ang kanyang series, arithmetic series, pwedeng n term times the quantity of first term and last term all over 2. Itong arithmetic series na to, ito yung ginamit ni ang formula na to ay na-contribute naman ni tinatawag natin ni Carl Gauss or yung tinatawag na Carl Gauss. Yan, siya nag-contribute niyang kanyang arithmetic series na yan. Kung dito sa term na to, hindi mo makita yung kasi dito sa formula na to, hindi mo pa directly alam kung anong common difference. Pwede ka rin naman gumamit ng arithmetic series na merong given ang n term at saka yung kanyang common difference. Ito naman yung kanyang equality. So, n is equal to the 2 times the first term plus n minus 1 times the common difference all over 2. Parehas lang yung equation na yan or yung formula na yan. So, depende nga sa given information na makukuha mo. Kung merong common difference, pwede mong gamitin ang second equation. Kung given naman ang first and last term, pwede na itong first equation. So, yan ay mga tinatawag nating arithmetic sequence and arithmetic series. Next, meron din tayong tinatawag na sequence under geometric. Okay, paano naman tong geometric sequence? Geometric sequence is a sequence in which each term after the first is obtained by multiplying. Yan, yung kanina, adding. Ngayon naman, multiplying the preceding term. Kaya constant. So, yung constant na yun, tinatawag naman siyang common ratio. At yung common ratio ay in the form of, so yung nakikita nyo ngayon, ito yung ating geometric sequence. A sub n is equals to the first term, a sub 1, times the common ratio raised to the number of term minus 1. Ito ngayon ang kanyang magiging geometric sequence. At yung kanyang geometric series, a sub n, pwedeng kapag ang kanyang common ratio ay 1, i-times mo lang, number of terms times first term. Yan. Sa common ratio ay 1. Pero kapag not 1 ang kanyang common ratio, ito naman ang iyong magiging geometric series. A sub n is equals to the first term times 1 minus common ratio raised to n, number of terms, all over 1 minus common ratio. And we can use this if the value of common ratio is not equal to 1. Ayan. So, that is geometric sequence. Next, yes, meron din tayong tinatawag na infinite geometric series. Yung kaninang nakita nyo, that is for finite geometric series. What if yung given information natin is under the infinite geometric series? So, ito ang requirements para masabi natin na siya ay under ng infinite geometric series. If the value of common ratio below or greater than negative 1 but under 1. So, in between negative 1 and 1, yung ating common ratio. So, pwedeng maging ano yan, infinite geometric series. So, it is in the form of first term plus first term times common ratio plus first term times common ratio squared plus and so on up to the last term. First term times r raised to n minus 1 has a sum and given by, ito ang gagamitin natin na kanyang infinite geometric series. First term all over 1 minus common ratio. Okay? Next, meron din mga tinatawag na arithmetic sequence na nag-undergo with the harmonic sequence. So, paano magiging harmonic? Ito ang kanyang definition. If the set of A sub n is an arithmetic sequence, then the sequence with the n term P sub n is equals to 1 over A sub n is harmonic sequence. Mapapansin mo yung kanyang pagka-sequence ay yung masasabi nating multiplicative inverse ng given arithmetic sequence. So, kung merong given arithmetic sequence, then yung sequence ng kanyang multiplicative inverse ay pwedeng tawaging harmonic sequence. Okay. Kaya connected din yan. So, kaya ang harmonic ay naka-base din sa arithmetic kapag meron ng tinatawag na multiplicative inverse. Okay, so dito tayo sa mga examples ng mga binigay natin kanina. So first, example 2 natin. Yes, ang nakalagay doon na arithmetic sequence. How many terms are there? Okay, how many terms are there in the arithmetic sequence with first term? Ang first term daw ay 5. First term. Ngayon tinatanong, ilan ang kanyang terms or ilan? Parang ganyan yan, di ba? Hindi natin alam kung ilan nga yan. Tapos, pero binigay niya yung last term. Ang last term daw ay negative 76. Ganyan ang parang magiging sketching yon. Tapos, may common difference na minus 3. So, ibig sabihin, ang susunod na term ay, kung ima-minus mo, di ba? 5 minus 3, ang susunod ay 2. Ganun. So, ang tanong ay, ilang terms bago makarating ng negative 76? So, pwede ang gawin mong way, ayan, manual, di ba? Isa-isahin mo. Or, pwedeng gumamit ng formula. Okay? Yan. Yun ang dalawang gateway. Mag-manual ka, puro minus 3 lang ng minus 3. Or, yung formula. Okay, tingnan natin naman kapag formula ang ginamit. So, ang first term natin ay 5. Common difference, negative 3. At yung last term ay negative 76. Negative 76. So, yun yung nasa ating example. Then, ang question, find n or yung tinatawag na number of terms. So, using the formula, last term equals first term plus number of term minus 1 times common difference. And last term natin ay negative 76. So, ang target natin ay yung n. Itong n. Yan yung target. Okay? So, ano lang yan? Algebraic manipulation. Diba? So, negative 76. Tapos yung 5 natin na nasa left, dali mo lang sa right, magiging minus 5. At yung negative 3, dahil siya ay factor, pwede siya maging denominator nung nasa right. Then, may iwan lang yung n minus 1. So, continuation ng ating manipulation. So, magiging n minus 1 equals 27. Negative 76 minus 5 all over negative 3 is 27. Then, ang magiging number of terms, 28. Ayan. Kaya, merong 28. Kasama na yung ano doon na, first and last term. So, ang first term ay 5 at yung pang 28 term, negative 76. Ito lang, check na. Nakuha natin yung number of terms. Yun lang naman yung kailangan. Okay? Next, bigay pa tayo ng another example. Okay, sa example 3, list the first 3 terms of the arithmetic sequence if the 25th term is 35 and the 30th term is 5. Medyo malayo na yung pagitan, di ba? Ang hinihingi lang, tingnan natin yung scenario muna. Ang hinihingi ay yung first 3 terms. So, blank, blank, and blank. Wala tayong first term ha. Kasi yun nga yung nasa question eh. So ito, tanong na agad yan. Ano yung first three term na yan? Pero may binigay na information. Ang sabi, yung pang 25 daw ay, let's say ito yung pang 25 na term, ay 35. Pang 25 to ha. So lumalabas na siya yung A sub 25. Ito yung A sub 25. Tapos naputol uli. Wala nang A sub 26. Nawala na uli siya. Ang sumunod ng ibinigay ay A sub 30, yung pang 30 na term. Yun daw ay 5. So ang tinatanong, ano yung first term? A sub 1, ano yung A sub 2, at yung A sub 3. Ayan, parang ganyan yung magiging sequence. Okay? So, check natin kung paano ang ginawang solution dyan. So, ang mangyayari ngayon ay yung kuhanin muna natin yung given dun sa 25th, yung pwedeng maging form of equation. So, 25th term, A sub 25 is the same as first term. Wala pa tayong first term, missing nga yun eh. Plus 24D. Bakit 24? Kasi from 25, di ba 25 minus 1. So 24D na lang. Yung D, wala rin tayong common difference. Kasi nga blanco-blanco eh. Kumbaga, ang layo ng mga pagitan. Equals 35. Kasi yung pang 25 na term ay 35. At doon naman sa equation ng pang 30th term, first term missing, nanggaling yung 29 sa 30 minus 1, kaya 29. Common difference missing, at iyon ay 5. Ngayon, itong dalawang equation na to, pwede nating gawin system, di ba? Meron naman tayong paraan sa system. So, elimination. Ano ang mangyayari? May eliminate na yung A sub 1. Kasi A sub 1 minus A sub 1. Kaya, cancel out na to. Ang sumunod, 24 minus 29D, meron tayong negative 5D. So, ang makukuha pala natin dito ay yung common difference. Then, 35 minus 5, 30. So, makukuha natin ang common difference. Malinaw, no? Na makukuha natin ang common difference. At ang common difference ay negative 6. Okay. Importante yung common difference. Kasi ito yung magiging constant para matuloy natin yung ating bawat terms. Okay? So, kung meron tayong common difference, ibig sabihin, pwede mo nang gamitin itong common difference, para makuha natin ang first term. Gamitin natin yung pang 24th term na equation, or 25 term. Dito, yung 25 term. So, ang 25 terms natin ay first term plus 24 times common difference, negative 6, which is equal to 35. Kapag ginamit natin yung equation na yan, makukuha natin yung first term. Diba? So, magiging first term natin ay 179. Okay. So, nanggaling yung sa 24 times negative 6. So, pag kinuha natin yan ay meron kang negative 24. Yan. Okay. 24. Tapos 12, 14. Tama ba? Ayan. Tapos, meron pa tayong 35. Kasi ito, di ba, negative yan. Negative 144. Kaso dadali mo yan, yung negative 144, pag dinala mo na sa left side, magiging plus na. Plus 35. Okay, so 144 plus 35, that is 179. So, check na tayo sa first term. Madali na. Nakuha mo na yung first term. So, makukuha mo na yung second term. Ang gagawin mo lang, minus 6. At yung third term, yung result ng second term, minus 6 ulit. Okay? Yun lang naman ang kailangan natin, di ba? First, second, and third. Okay, so the first term are the first three terms, 179 first term minus 6, 173 minus 6, 167. And that's it. Okay. Ayan. Kaya pa ba ng sa pang example? Kaya pa, no? Last example na lang. Ito. Example 4. Find the sum of all positive 3-digit odd integers. Okay? Okay, for the solution, syempre pag kinuha natin ang tinatanong doon yung series, no? Kasi find the sum eh. So, series na yan. So, find the series or S of n if the first term is 101 and that is the same with 1 plus 50 times 2. 101 din yan, di ba? So, ang last term naman, first term yun at ang last term ay 999. Kasi 999 ito ay add, di ba? So, nanggaling naman yun sa 1 plus 499 times 2. And that is 999. Ngayon, ang gagawin natin, there are 450 terms from first term to last term. 450 terms. Yan. Ang binibilang natin dito, yung mga positive odd integers. So, using the series, gamit yung first formula, yung total terms times the first term plus the last term divided by 2. So, ang magiging series natin ngayon ay 247,500. Yan na ngayon na magiging total. Galing din yan sa computation dito sa ating formula.